Last episode you cleaned pixels up, resized, cropped, normalized, fixed the D-type. Clean pixels are still just brightness. Now we ask the question every vision model starts with: where does one thing end and the next begin? That's an edge. And an edge is nothing mystical. It's a place where the numbers change fast. Let me show you how Blur, Sobel and Canny turn flat pixels into structure. Here's a grayscale image as it really is. A grid of numbers, 0 for black, 255 for white, walk across a row. Inside the shape, the numbers barely move, but at the boundary they jump from 20 to 200 in one step. That jump is the edge. Everything today is about measuring that jump. The jump has a name, the gradient. Sobel slides a tiny 3x3 stencil across the image and asks, at each pixel, how steeply is brightness rising left to right and top to bottom? Two numbers per pixel. Combine them and you get a magnitude, high on the rim of the shape, near 0 everywhere, flat. That magnitude image already glows along the outline, but raw gradients are jittery. One noisy pixel spikes the magnitude and you get a fake speckle of edges. So first you blur. A Gaussian smooths each pixel toward its neighbors, killing the single pixel noise without erasing the real boundary. Blur a little, and the true edge survives while the speckles flatten out. Smooth, then differentiate. Canny ties it together. Blur, take the Sobel gradient, then thin every ridge down to one crisp pixel wide, and finally keep an edge only if it's strong, or if it's weak but touching something strong. Two thresholds, one connected map. The output is binary, 255 where there's an edge, 0 everywhere else. Now we can count them. Here's the program, no download. We paint our own image with NumPy. A 200 by 200 gray canvas, then a white filled rectangle and a white circle stamped in, seeded, offline, identical every run. This is our shape image, the input to the whole pipeline. We convert to uint8 and confirm the shape, 200 by 200 single channel, D-type uint8. Pixel values are only 60 for the background and 255 for the shapes, so the boundaries are sharp and honest before we touch a filter. First, CV2 out Gaussian blur with a 5x5 kernel. That's the noise suppression step. It slightly softens the hard edges, so Canny traces one clean line per boundary instead of a doubled ribbon. Then CV2 Canny on the blurred image with thresholds 50 and 150. Canny returns an array the same size as the image, full of zeros and 255s. We count the edge pixels with int, edges 255, sum, that single number is the headline. We also grab the gradient magnitude from Sobel, just to confirm the edges sit exactly where the gradient peaks. Run it. The terminal prints the image shape, the unique input values, the blur kernel, the Canny thresholds, and the edge pixel count. Then it runs the entire pipeline a second time and asserts the two edge maps are byte for byte identical, reproducible to the pixel. Last line asserts the number painted on the figure equals the number the terminal computed. The figure can't drift from the run. One source of truth checked in code. So an edge is a gradient and Canny is just blur differentiate thin threshold. Pixels become a thin map of structure. But a map of edges isn't yet a list of objects. Next episode we threshold and pull out contours, turning these glowing outlines into countable, measurable shapes, edges to features.